There we go. Afternoon, everybody. I think it's been a heavy day of information and data and digitalization. Unfortunately, I've got another one of those sessions. But I hope to bring you down from the 20th floor of PLM, maybe down to something more your level. I made an interesting couple of observations with the last presentation. I think the first observation was the fact that once you saw the nice pictures of the ship, there was a lift of energy in the room. You saw something tangible rather than the kind of dry website of PLM. Unfortunately, that's a reality. I can do something about that. I can give you a nice 3D model to work with. I think another thing that I saw as an observation was that the voice of Alston highlighted many terms that are not strictly PLM issues. They're issues of communication, of synchronization, of knowing what other members of your team are doing. And if I was to summarize eShare in that respect, we solve those problems. We don't necessarily solve the big PLM problem. So let's head into my presentation. There we go. So my presentation, kind of three parts. We're going to start looking at the human side, looking at the ideas that I expressed with Alston's voice, the consistency side, and kind of get deeper into what eShare does. I'm going to give you a live demo, and then we're going to follow that with what our customers did. And I think it's nice to see what customers do because it shows you how they use the software. You're not having to listen to me and what I think you should be doing. Following my presentation, we're going to hand over to Lurs and Kroger, and they're going to show us what they did. So let's head on in. So we've heard about data-centric, all the digitalizations. It's almost as if the machines are taking control. I disagree with that reality completely. If machines were taking over the ship design and the ship manufacturing process, well, what interest would there be for us? So if I was to say, what are the pillars on which we base this on? You'll say, well, yes, this is obvious. Let's go into it. You know, if you let immature engineering information reach production, then painful things happen. It's obvious. But how do you stop that from happening? You have some experts. You have experience from all over piping, hull. And to stop that immature information getting to manufacturing, well, you deploy your experts. You stop them. You use their experience. But they don't work unless they're talking to each other. They have to synchronize to ensure that maturity grows. And ideally, you want to grow in a controllable and progressive way, in an early way. I did notice that there was shift left mentioned in some of the topics there. So this is the kind of three foundations. But this is not enough. With this, we still cannot grow in ourselves. We still need a learning aspect. We need continual improvement of quality because as experts, tomorrow we want to do better. Tomorrow we want to build a more effective, more cost-effective, greener ship. So this really is what we're trying to do, and in some respects, the software is there to make life easier. So communication is the thing that will give us consistency. We have to talk to each other. But I'm not talking about having meetings or conversations. Those are reserved for the important stuff. What about the low-level, low-value communication that can just be done through software? That is where the software can help us and let us focus on the more important things. So, heading for consistency. Consistency of information, consistency of design and processes. I think you understand this concept. Measure twice, cut once. You're doing some work on your house. If you cut something too short and you don't have enough materials, well, then you might be done for the day. You can't finish the job, you need some new. It kind of hurts. It doesn't always have to hurt in this method. I once was fixing my heating system on a Saturday night. And it happened to be the Easter weekend. And in the UK, on Easter weekend, the shops are closed on Sunday. So I cannot now buy what I need to fix the heating system tonight or tomorrow. So rather than a pain, I was cold instead. So we can understand the costs and the time delays associated with this act. It's a direct impact on us. But our projects are far more complicated. We have a lot of information where those simple inconsistencies, we're not yet at the manufacturing stage, but if some information isn't connected, isn't accurately connected, you have a problem of a little monster at some point that's ready to cause you cost and delay at some point in the future if you don't sort it out. And you could call those "if only I'd known." Those "if only I'd knowns" featured heavily in Alston's voice of their team. But what about a big manufacturing project where we have lots of people? They should be communicating, but these days we have challenges in the way we work. While we do use big data systems, we also use a lot of documents, a lot of data sources. They are not heavily connected. Be nice to do everything, but the reality today is that they aren't. And as we head closer to manufacturing, well, those costs and delays can get more important if they get to the stage where they appear in manufacturing. And obviously, we design our processes so that doesn't happen. But that means that there are a certain size of mistake that could get through. Well, is there a way we could bring them even more to the left to make that even cheaper? So it's interesting that we started the day talking about data-driven systems. And when I think about kind of my early days of my career, when I used to research ship design systems, I think about maybe as far as before I was born in the 70s, we were building data-driven systems then. So if the answer is data-driven on its own, what's the problem? We already do this. And I've been thinking about this maybe since joining the team about what's the real issue here? Is it a technical, software, or is it a human problem? Well, I think it's a human problem. Having worked with software, mostly CAD and production, the last 2 decades, I know that when you work with the engineering team, they have a nice expert system, does everything they need. Well, most of the time it does everything they need, and you can see they're all happy. They can design beautiful structure, beautiful piping. They're cool in their little engineering world. And then you have the planning and the scheduling team. Well, they have a nice system. You know, it all works well, they're happy. Of course, we've got production as well. But do engineering and scheduling and production talk together? That is a bit of a challenge. In my experience, yes, we'd like to create interfaces between these systems, but all of these systems are what I would call systems for experts. And designing interfaces for them is quite challenging because you have to translate one expert's understanding of the world to another expert's understanding of the world. I, in my early days, used to do this as a nice challenge for free. And then I found out what the commercial world was charging for these things, which was typically 6-figure numbers. And I stopped doing that because, well, why am I doing this for free? But that's the reality of trying to exchange information. That probably talks a lot about what I've done in the background for a lot of my career, connecting information together. So what's the problem? Well, we've already said a lack of visibility between these systems creates those opportunities for those mistakes to grow. How have we traditionally addressed this? Well, we've done this through manual verification. We've used slow and discrete processes, such as review meetings. Is this effective use of experts' time? They tend to get bored in these kind of situations, the manual checking. And as human processes, there's no guarantee that all of these issues will be identified. Something will get through. And if you then put your business hat on, your manager's hat, how will you collect information from this system to understand where things are going wrong and where you'd like to target your improvements? The ability to get insight from how this system is functioning is actually quite challenging. So how do we deal with this? We produce outputs, all types of outputs, drawings, Excel spreadsheets, documents. We stick them in the email. Who knows what version you've got? A system like PLM is designed to control this, but not everyone works in this side of system. Not every customer is big enough to really embrace PLM. There's a challenge in getting into that. Is there a simpler way we could do this? What is the problem we're dealing with? So typical bottlenecks, going back to almost the voice of Olston again, not being informed of something. I don't have access to that information because I don't work in that department, or I haven't got a login, or I haven't been trained in how to use that system. We get waiting, delays for information. Finding stuff was brought up already. But what happens if you have to talk to someone directly, or if you have to engage around this in a meeting? Then this isn't so efficient. We also have the concept of having to transform information from one format to another. Sometimes from one data system to another. Someone writes a script, a macro, that has to be controlled. But what about from documents to a data system? This is not necessarily an efficient process if you have to update things. And a final one, let's call it traveling for knowledge. I'm not necessarily talking about flying, but how do you know that the information that you have is the truth, say, from another production yard? Sometimes some people have said that the only way to know this is to physically travel there and ask about it. So it's that idea of getting information back from those locations, and sometimes with the concept of things like IoT, we can get information back, but just the routine aspect of bringing information together is somewhat a challenge for some customers. So let's bring this down to something that could happen to each of us. Here you see on my screen, have a valve highlighted. I get a phone call from procurement, and they said, we've had an email that says that the delivery of the additional valves is not coming. Unfortunately, the company have gone bankrupt. I work in procurement. It's not my problem. Over to you. So what are you going to do? Well, you're good. You're going to make a nice action list. So let's start at the beginning. What's the scale of the problem? How many valves have I got? Well, this is an engineering problem. You go into the engineering system. How many were delivered? Well, this is a procurement problem. Let's need to go to the procurement system. Did we start production? Well, we get the production system. How many are fitted? This information could be contained within multiple systems that are not necessarily talking to each other. Let's go on to the deeper questions. What's the impact on project delivery? How am I going to calculate this? I've already been introduced as a naval architect. I start thinking, well, am I going to give the ship owner a headache by having a new set of maintenance inventory because we just replaced the remaining valves? Or should we think about changing all the valves? I'll talk to the customer about that. OK, now I have to do the real work, the consequence on the engineering change, calculation of cost and hours. And only once I have done that will I talk to management, because maybe I'm a bit scared. And at that point, then we can instigate the change management process. I should probably also tell production that maybe there are some things that they should stop. So, there's a lot of different systems that I need to access to get that information. And if I don't have the ability to access all those systems myself, then I'm going to need to talk to people because they have the training to access that information. It's going to take a lot longer. I cannot, in an agile way, adapt to this situation. So how big could this problem potentially be? Well, we've talked about engineering and production. They're typically the ones that own the 3D, the PLM, the ERP. And I would say, in general, they're pretty good at communicating. They're pretty good at synchronizing, because without that, they wouldn't be able to build the complicated ships they have today. But what about beyond this? What about manufacturing and commissioning process? Traditionally, we've relied on the maturity review to be the gateway of getting information from one system to another. We can communicate with them. They can understand if there are some open issues, as was put earlier, or understand if there's going to be something that's going to affect them. But why stop there? Why don't we involve functional design? What happens if functional design detect an issue with the vessel, quite a high-risk one, and they need to know what the impact of making this change is? There might be other changes that solve that problem. So they need feedback from the engineering and the production process to allow them to make their best judgment of how to proceed. OK, we've got the logical engineering process. How about the management team? The management team is often the group that starts to introduce things like PLM, because they don't have access to the information in the expert systems, because they are not experts. So we need to involve them. So just within our organization, we have a complicated web of interactions. Again, why stop there? Why could we not involve the customer in this? Also, your subcontractors, they probably need to communicate with you not only at the engineering phase, but there are a lot of production subcontractors. Why not give them the opportunity to feed into your project, tell you what the status they're at? So we have the potential to make a messy communication diagram here. We don't advocate having this as your ambition as a first step because it's going to make life quite complicated. But there might be a group that you want to build that first step of iterative communication with something like eShare. So now we start to move to eShare. How are we going to help these teams? Well, rather than taking all the expert information, we take the important information that is relevant to the project, to the engineering. We keep a lot of information back. And this way, we can simplify a view on it. We can take all of those documents, but organize them, make them in an accessible way, and in some cases, almost going as far as turning documents into a data-driven experience. And then what we do, we give them a web interface back. They each have a consistent view on the project with all of the data from all of the shared systems, so they do not have to go physically to another system to extract information to understand what's going on. So what are we doing? We're building a single source of truth, but crucially, and different to Wave, this is based on existing systems. Your existing systems that we extract data from, data documents. eShare in itself is not something that stores any data itself. It takes that from other systems. So in that respect, its first job is to do some publishing, deploying the information, the knowledge, across your organization, either as a web-based app or as a mobile app. That gives you the opportunity to, rather than wait for specific review processes, you can access it at any time, review, and give feedback. And then you can start to think about using some more innovative use of the tool, such as automatically identifying inconsistencies, creating rule-based processes to look for information that is not matching up. And then we'll put our manager's hat back on. We can look at how the project is proceeding and capture any insight about where things are not necessarily going as fast as we expect. And these are indeed facts, which you can use to support business cases. Get some more investment, bigger team, or maybe better equipment. So this is what it looks like. It's a web page. You've seen a whole lot of web pages in the last session, but here you can start to see a physical connection with the project you're working on. You've got context. So I call it making the workflow, making it easier. What are we doing? So we're facilitating traceable communication. We're using the digital tools for that. We're synchronizing data and documents within the team so they all have consistent knowledge. We're giving them the opportunity to feedback. That could be just simple commenting, but some of those comments could be as powerful to start to instigate change. So we're not talking about us doing change management, but we're talking about raising an issue that might start a change in another system. We're using digitalization to translate data and documents into something that's easily readable, consistent across the system. And we seek out those opportunities to automate consistency checks. And then you have the opportunity to use all of that information over time to expose insights about how your project is running. So I'm now going to move towards a live demo. But before I do that, I'd like to show you some of the highlights of what you'll see. So you'll see a web browser with a 3D model. Many of your first impressions, having seen eBrowser for many years, is, it's eBrowser in a website. Well, yes, the graphics themselves are powered by the same tools as eBrowser, but there's a lot more going on around the outside. There's drawings in the same environment, and documents, and other things, which we'll go on to. You can visualize the data your way. We have a breakdown structure here. That could be based on the model. but the system supports the creation of many other data structures on the fly that might be more suitable to how you understand your world. So whether you understand it from the material perspective, from a specification perspective, or from a procurement status, you can then go into the 3D model and see how the model is broken down in that respect. And I'll show you more about that in context with the whole user interface in a minute. You can create these breakdown structures whenever you want as an admin process. You're not having to create them at the start of the process. You, of course, get your model information, but then, in exactly the same style, you can bring that data in from other systems. So you could bring your work packaging information, your ERP information, your change requests, PLM, status. What you want to bring in is up to you, depending on how far you want to take your system. And you might not want everybody to see the same thing. So you can control this based on user roles. But it's fairly simple to bring this in, and it's pretty much live information. It's extracted from the external system as you visualize it. Being a 3D model, it's obviously got colors and connections. So in addition to those links, you might see attachments to documents. If you click on those documents, not only will it open the document, but it'll take you to the location in that document where that information is referred to. So, there is that plate. If you browse, you'll go around all of the references to that plate in that document. And because that number is also a hyperlink, click on it, it will take you back. Or click on another number, and it will take you to that relevant part. So that whole challenge of searching to find information is made far more easier because the collection of information is right there. Of course, you don't have to color the model based on what you see in engineering. Here we see a view where the model has been colored based on information inside a nesting system. We're synchronizing between those two. So this is the model showing system information. Equally, the model could be showing process information. So synchronizing our engineering manufacturing guys here, simply understanding where the project is by coloring pipes in different colors. I think you don't need me to explain this because it's fairly obvious when you see on screen what's going on. And then you can take that power a little bit further by highlighting those inconsistencies in your project. So here we have some fields with some highlights. We can see that they are not matching up. They're behaving in a slightly different way to all the other parameters. You can also show that on a drawing. We have some red issues there. You easily see those items are not happy. They're red, not green. We can start to look into those to see what the problem is. So let's have a look at eShare. And I will have a little drink. So those familiar with eBrowser might feel that this is a familiar screen. Yes, as I said, this is very much the graphics taken from eBrowser, but put inside a website and given the ability to do lots more things. The model and process is exactly the same as you would experience in eBrowser. We have a tree structure, but we have far more easier access to a lot of the parameters than you currently get in eBrowser. But that's not the only way of visualizing the project. This morning, JV talked about the map. I think this is a strange terminology for a marine company to introduce because I see this as a digital general arrangement. This gives me the ability to swap between each of the views of the vessel. Now, probably you're all engineers and used to seeing a 3D model, so you're comfortable with that. But in my experience, there are some people working with operators. You show them a 3D model, they're a little bit uncomfortable with that. They can get far better kind of access to what you're trying to talk to them around if they see a 2D plan. Well, there's a 2D plan. You could also see where my camera was. We also have access to documents. These documents are not in eShare, they're retrieved from wherever you want to collect them from. Could be your file system, could be your document management system, or multiple document management systems. So you can get this idea, eShare is sucking in all of this information and allowing me to access it here. What have we got in here? We have, oh, that's Excel. Let's have a look in Excel. Something different, Excel doesn't show directly, but I can get access to that Excel sheet straight from here. So let's go a little bit deeper and understand the flow of information between the different systems. I'm going to be spending most of the demo in this little compartment. We're in the aft end. Back here, this is a propulsion motor above an azimuth drive. And if I click on that propulsion motor, it gives me information that you can see. If you just read it, we have a model, equipment management data, maturity management. You have no idea where this information comes from. And is that not the point? You're not worried about how this is implemented. In fact, this equipment management data is coming from an Excel spreadsheet. If I click on my pipe over here, I get a different description. I get input from the PLM system. So this idea, this opportunity to bring this information into our same environment with access to the 3D model gives us the ability to go to those data sets really quickly. And because of this ease, maybe you start to understand why eShare is a strong part of Wave, because Wave is another system of information, much like all the others we're connecting to. So, clicking on our motor here, if I wanted to look at the service manual. Service manual is listed in my section of documents. It will load this up. Now this is 142 pages, so it's not a small document, it takes a little while. But I know that if I go to page 14, I've got the installation information, lifting of the propulsion unit itself. If I go back to the 3D model, we've got a coordination drawing. Again, it's a fairly significant document. It'll load it up, and we can see the propulsion motor here. You can actually see over here, we've got one of two. There is another location where the propulsion motor is shown. So I can see that all of the locations in this document where that propulsion motor is shown. Oh, and this is interesting. There's a lube oil unit. I didn't see that in my 3D model. Click on it. Lube oil module was hiding behind the propulsion motor, and it takes me directly to it. Bit of systems, we can do the same kind of idea. Clicking on the cooling pipe there will take me to the system isometric. Again, focus is in, and we can see that valve earlier that was cancelled by procurement, and all the references there. So I can zoom out and browse the kind of circuits. In fact, I have four circuits here, each for the two propulsion motors. We have some other things going on in a more forward compartment, and we have some keel coolers. Let's head into the keel coolers. Naturally, eShare takes me to that location, and we can. I probably hit everything. I did. That was unfortunate. We'll just get it back. There we go. So we could just adjust the view to get hold of the cooler. And we can see down here, we got access to the same documents, but also the supplier info for that cooler. Again, this ease of searching through the model, it's very comfortable. Doesn't require a lot of training. In fact, people can just figure this out on their own if they really want to. Okay. So let's have a little bit of a deeper look into what's going on with some of the other stuff. So I talked earlier about the breakdown structures. JV this morning mentioned about the dynamic breakdown structures. This is something new coming along where a breakdown structure can be built from multiple data sources at the same time. Well, the version I'm using is not the same version, so what we have is either coming from the model or a data source. So our model gives us breakdowns around systems, around compartments, and these are typically the standard breakdown structures that you might set up in your project and just replicate it into eShare. But maybe we should look at some other ones. So earlier I mentioned about a nesting name. So just going to the nesting here, it brings me a list of nested parts. Let's get rid of some of the other stuff. There we go. And we have a point cloud as well. So having hid things that are not part of nesting, we are only left with the parts that are inside the nesting system. This is a separate nesting system. It's not part of eShare. We're just bringing that data in. And of course, we can browse. So this nest here happens to contain these parts. We can browse through them. So this is one way of looking at the information. Let's combine that with a visual style. Let's use the visual style to show us what parts are fully nested in red and fully cut, so that we know that the green parts have already been made, the red parts have been nested, but they have not been committed to material yet. So if you really want to, you can change them with a level of pain, but the green ones, probably not a good idea to ask for any changes in those areas. But we can quickly see feedback to answer that question, can I make a change in this area, very quickly. So that was very much a system view or a data view of our project. Let's go back into our propulsion room and ask another question. Let's ask, and this is done in a very simple way, what is the status of my parts? And you can see that there's a lot of parts that are gray. They currently have no information. And again, I'm focusing on that cooling water system. The breakdown structure can also give me the same information, but as a tree. And if I hide those elements that have no status, then we can see those elements in the project that just have status information associated with them. I want to just focus on this system here. So let's hide the unselected parts. There we go. So here is my cooling water system, and we can see some greens, some reds, and some blues. This is a very simple system, so you can easily see on screen. Green is in engineering, blue approved for production, and red in production. So let's change some of those aspects. Let's select these items here, and we're going to change them to approved for production. You see that I can't immediately take them all the way to production. There is a process to be followed. And as we do that, it appears in blue. So immediately, it's updated. Select the right ones. Again, you can see I don't have to select all of the parts. I only have to select parts of a relevant spool, for example. Here, these have been approved for production so that we can move them on to production. Those parts go red. So this is a logical use of a 3D model. But it's not the only way of looking at this information. Let's have a look at our system isometric. We had this earlier. And I might need to hunt around a little bit to find this. I'm used to using a slightly different version of the software, so I know where I've been clicking previously, but now the button has moved. Here we go. So the system is running away thinking, and it's going to give me an updated view of this drawing. In fact, it's actually regenerating the whole drawing, as you'll see. There we go. So now we have a view where we have colored links. Those blue pipes now have blue labels. The red pipes have red labels. You can now save this as a PDF and have a separate documentation where this is illustrated. Or if you have that person that is not so good with accessing information in 3D, they have a drawing to access to get this information. So we're able to present the same information in lots of different formats, allow a variety of people to understand what's going on. So as a final little bit of the demo, we'll start to instigate a little bit of change. So you may remember this valve from my earlier picture. Well, it's now gone on to commissioning, and we have a little bit of an issue. Unfortunately, it failed during the commissioning process, and we've got a bit of a leak. So let's create a markup around that. Here we go. Turn that around. So we can create an annotated view. We can add some text. Let's give it a title. There we go. So you can see that I've run this demo before. We require a replacement regulation valve. I can assign it to myself. It's new. I'm going to say, actually, this is quite high importance because everything is waiting on this. And we have a commenting process. So we could say valve failed during testing. And I could go on and go forth. I can even, if I was in the field using the mobile application, associate a photo with this. We'll go and find the photo. There we go. I've created it and say, hey, someone now needs to sort this out. Then my job might be to come in, check these out, and we can see we have a feed of different comments, different changes that might be needed. I can respond to those things. I can see here something's been replaced. I have access to the photos. Something seriously went wrong. I need to make that replacement. So what I can do is then update it. I can approve that and say, new valve on the way, so on and so forth. Now, we're not initiating a change at this point. We haven't gone into a change management system, but this is enough for someone to make a comment and start that process from moving onwards. You'll see probably with some further development of Wave that this could physically, as a digital process, feed into that change management process. But as eShare is working very much in a standalone way here, it's really feeding into the other systems that you might be using. OK, so I will leave the demonstration there for a while. The second part of the presentation, I'd like to talk about what our customers did and some of the things that they do. Of course, when you ask this question, customers will give you a big list of all the things they've done. So I've tried to turn it into something a little bit more categorized, interesting. What is the, if I did a breakdown of things that I see that they do, well, the first thing that they do is something that I would call centralized reporting. They go to eShare to find out something. And that gives that synchronization between teams' knowledge. It highlights areas that they might need to watch, and if you were a manager, maybe say, hey, I need to ask this team some questions because I don't understand why this is not coming together. And that also then leads on to other tests, other checks that they might do. Can I automatically expose mistakes in the data because there's inconsistent information? So really what we're kind of starting to do is giving the engineers the opportunity to self-check their work before they proceed on in the reviewing process, which should mean that when it gets to the larger review that happens between different people, it should be a little bit easier, but it also means that you might be able to have different levels of review. So an individual person might be able to approve something if it's a logical movement of the process. But if you're working through a significant engineering challenge, you might want to refer that to a proper team review meeting. eShare also allows you to start to integrate supporting documentation. Now, this is probably more of a manufacturing concept, but there's a lot of documents that aren't generated in respect to the engineering model, the 3D model. They're kind of supporting a process, and as such, they don't have a reference that kind of connects to anything. We have ways of making them come into the model. So if I was to talk about reporting, well, let's just define the concept. eShare sits as a tool that collects information. We've highlighted how it brings in 3D models, data files, files from your file manager. But it can also access databases, and in the modern world, it also has the ability to use web APIs, so it can connect to cloud systems. For example, PLM, Jira, lots of different systems have this kind of idea of a web API. It's the modern solution to integration. We have lots of different tools that we currently work with. These are the major ones that are being used in the marine sector. We have an equal list of tools that are used in the plant sector. So this information goes into eShare. What do we do with it? Well, I say the first opportunity should be the concept of using your eyes. It's one of the things that are said to junior officers on the bridge, that they should stop looking at their monitors and look out the window. Well, it's probably a good thing to get an appreciation of what's going on if you just have a look. But then you have those things that I was doing earlier in eShare, use of the categorization, the breakdown structure, and the visual styles. Then you have customers thinking big ideas, their innovative use. Now, those are always much harder to describe and always one-offs, unique to customers. But if I was to categorize one common use, we're seeing quite a significant use of something like Power BI to connect to eShare and use that as a data source, summarize information in a dashboarding way. So here is an example. We see a pump highlighted. We're bringing together information from the P&ID system and also an equipment system. And then one customer has this huge list of reports. If I was to categorize them, we have reports that do checks of information on consistency between different sources, logical one. We have reports that indicate how an object, a penetration, is moving through the manufacturing and approval process. Some of this relates to class, some of this relates to the manufacturing process. We can display and bring in information from subcontractors. Subcontractors have access to this web page. If they feed in information, then you can bring that and amalgamate that on top of your model. You see how the progress is happening at the subcontractor before they've even delivered your equipment. And you don't have to call them. This, by one customer, has been taken a little bit further. Rather than manually capture where things are in their process, they've fitted RFID tags to their spools, and they use a sensor to find out if the spool is in the location of where you're using it. So this means that you can find out if the RFID tag is at the manufacturer, you know it's there. If it's on its logistical journey to the shipyard, you can follow it there. You can find out if that spool has been installed. Now, obviously, the RFID system is not part of eShare, but eShare can connect to these kinds of systems to illustrate that data on the 3D model. Another example, another random one, a customer wanted to figure out a way of integrating sign-off information, inspection information into the model. I'll come to this one in a minute, but the challenge here is that the sign-off information itself has no physical reference to anything in your engineering system. It's just a sign-off document that covers a node of locations. However, it is performed in a certain location. It's got a spatial reference. That's something we can use. So all of these checks and reports are all generated in context with your 3D model. So, an example of highlighting the status of foundations in a subcontractor. We're both doing that with the breakdown structure on the left. We've got colors on the right. Blue items have been released for production. Gray items are on hold. Very easy to see what's going on. Now we're getting into the more the kind of checking process. Here we see some green valves, and we can see we've got green is the correct number on these valves. I'm color challenged, so I have not yet found where the red valves are, but you might be able to see them. And what we're doing, simply, we're taking information from a system and checking that the format of the name, the standard, fits what we expect. It's a very simple thing for a piece of software to do, a very boring thing for a human to do. Why do that with just one system? Here we can take information from two systems, for example, specification, the bore, check that the specification and bore is the same in all of the systems, and then illustrate that on the drawing. So, for example, we have some red items. I think they're down here. As I said, I'm colorblind. So you can see the red items, they have some issues. We also have some green items up there. Well, these objects haven't been found. Perhaps they're currently inside the drawing, but not in the 3D model yet. So all this information is immediately coming back to you. So those automatic checks could highlight that, say, for example, a field called PNID standard is different in two different systems. We see in the top one, it's got a nice little reference number. Down here, it looks like it just had the default number. Someone hasn't updated that. There's an action to be taken there. Similar kind of thing, this model has a field called BISTEC. In the 3D model, it has the value 3222. In the ERP system, it has the value 3211. Was that a typing mistake, or has there actually been a physical change? Connecting to the Trello system, another system that a customer might use. Here we can see between the green and the gray, which items have got a change indicated against them. It's very simple feedback. Not only kind of data, here we start to look at maybe some of the validation of the geometry itself. Two concepts. One is something aligned or misaligned? In this case, we're taking data from two different systems, one from Cadmatic Hull, one from Siemens Teamcenter, and we're looking just by visual inspection to see whether these items are actually in the same place. And using the two different colors, we can see that something doesn't look right. It needs further investigation. And then in terms of misalignment, well, the clash checking tool has been in the eBrowser for quite a few years, so it's something that we can leverage in eShare to make life a little easier. Again, another view of a combined model between Cadmatic Hull and Teamcenter. We've got blue and pink coming from the two systems. So, another area, driving maturity. The traditional maturity review process, at least with the customers I've worked in, have been big meetings. And I have the idea that if it doesn't pass the review meeting, then it goes back. How long did you wait for the review meeting to happen? So this is kind of a, it's a process that works, but it's engaging your experts in these meetings for long hours. In fact, a lot of the meetings that I kind of involved with, the experts started talking about football, so maybe they weren't so effective meetings. Why not use the technology to give the maturity route different opportunities? If something is simple and it's obvious that it should be passed just by another expert, then allow a single person check to move that on. But if they feel that it requires further review, why not then allocate it using the maturity process, status management, onto a review meeting? It gives you a far more flexible way of working. We can see that some of that taking place here. This is the view of all the penetrations in a ship, a small ship. You can see that the breakdown structure shows that some of these penetrations have sleeves and some have no sleeves. You can also see by the colors some of the penetrations having these states here. Some of them are the fact that the penetration is incomplete information. Some of them may be that that penetration has been removed or filled in. But you have a record of what is going on just in the 3D view. Of course, if you don't like something, you can make a comment, get something changed in a different way. I mentioned earlier about being able to incorporate documents into the process, so we could be talking about work instructions, sketches, notes, sometimes even paper that you need to scan in, you want to attach it. These could be all examples of kind of, not necessarily non-project, but documentation that doesn't originate in engineering. This was that example of that sign-off sheet. So this is a sheet that starts its life as paper. It's scanned in. Somewhere it has a reference number we can use, but it's not a reference number that's associated with any particular data in the project. So how do we connect it up? We can make a point in the model and associate that document with it. We then know that, say, in this space, this area has been reviewed, it's been surveyed, signed off, and that might be quite critical to a billing process if you're involved with subcontractors and they've implemented or installed those items. Final one for what our customers did, work packaging. Work packaging is quite a hot topic for us. We're starting to build up our ideas of how we should accommodate this. It's not a concept where the data should appear in just one system. It should be shared between a lot of systems, depending on what information you want to connect. I describe a work package of the what, how, when, where, and a who should be doing some work. And you can imagine there are already existing systems that overlap with this. The what's being, what are the parts? What are the prerequisite work packages? How is the associated work information, work instructions of how you're going to do it. And for us in Cadmatic, this is probably the most logical sets of data that we work with. But then you get the data from other systems that might need to be shown with that, maybe from planning, from your ERP system. When it comes to where, you may have constraints on where you can build something by weight, by its size. And then who is also important, but maybe not so important to eShare that we own that data, but we could find that from an associated system. And at this stage, we do things quite simply. So in terms of checking the how, if we click on an item, we can check that we have all the documents we expect to start building that item. Once we know that it's got all the documents, then we can update its status and allow it to proceed. The system can also allow us to collect the what, the parts involved. So here we've got some nice colors. We can see that we have the ability to use a drop-down box to associate these items with a particular work package. It can build a tree structure, and we can also use the colors to illustrate what's going on at this time. So we have documentation, work instructions, and a collection of objects. Put that together, we can start to have a breakdown structure with all the work instructions associated with that. Now, at the moment, we're at a very, I say, early stage in develop this, but this is something that we're probably going to be a main focus of eShare, I think, over the next coming years. So let's draw this presentation to a close. And if you've been interested in this, I'd like to tell you how simple it is to really get started with it. I've been working with eShare for a year, and this is the typical expectation of how long I take to set up a project. So we have the advantage of using a kind of an installation in the cloud that allows us to no longer have this on our personal systems, our machines, and any of my colleagues can go and work in my project. We start with a model, data, and documents. Customers just give us a selection of information that they want us to show working with eShare. Now, you can make a simple setup within a few hours. Document integration can take a bit longer. The challenge is not the integration of documents, but you have your own drawing information, your drawing numbers. We need to learn that. It takes a while. And that also means that things like basic workflow, they're fairly quick to implement in eShare, but learning how you do it sometimes takes a bit of discussion, talking with different people in your organization. But to show you how quick it can be, our 100th customer that was mentioned this morning was Gloucester. They challenged us to set up 2 pilots. This was not necessarily what we expected to happen, but after 2 days, they were showing eShare to their customer and already earning value. I don't think there's very many software out there that within 2 days of starting, you can already be generating value with that system. The ship owner that they were reviewing the modifications with, they received logins, they started to feedback, and they also engaged with the shipyard about the changes that they were making. I think this is quite impressive. So, closing out the presentation, we've talked a lot about the consistency of information and how we can use eShare to make your work flow. I did a live demo, and in the second part, I showed you some of the examples of the setups that our customers have made inside eShare, and I finished with the next steps. I'm now going to hand over to Nicholas from Nursen Kroger. He is, I cannot remember what his job title was, but he's going to show us how he uses eShare.